Hello, everyone. So today what we are going to do is we're going to handle some notes. We're going to take some notes on the force, mainly Newton's second law of conservation of mass. And from that, what we're going to do, we're going to finish the PhET simulation, um, and then we'll be good to go. Okay. So I believe this is where we picked or left off. Okay. We left off right on example 2, where Jonathan is playing with his favorite box, Carl, which he pushes. Carl has a mass of 10 kilograms. Okay, so we know the mass is 10 kilograms. Let me zoom in a little bit. So we know the mass is 10 kilograms. And then it says if the box starts from rest. So if it starts from rest, the initial velocity is 0. It goes 25 meters, and it reaches a speed of 6 meters per second. So that's our final. Can we use this information to help solve for acceleration? We can. Okay, so what it looks like is velocity final squared is equal to initial velocity squared plus 2a delta x. Okay, so if we plug in our numbers, we have 6 squared equals 0 squared, and we have 2a delta x is 25, okay? So 36 is equal to 50a. Divide the 50 over, so acceleration is equal to, I got 0.72. So if we're looking at force is equal to mass times acceleration, what you got to do is mass is 10 times that by 0.72. And if you do sig figs, force will be 7 newtons. Okay. And if there is at any time where you have to pause the video to solve the problems, that is fine, okay? So you can pause the videos. That is a great idea, okay? Next question. A constant net force acts on an object. Describe its motion. Okay, so a constant net force. So let's say you start at 0 and you add 3 kilometers or 3 meters per second. So you're going 3. Then you add 3 meters per second. So now you're going 6 meters per second. You add 3 meters per second. What happens is this means you're at a constant acceleration, right? You're constantly accelerating in the positive direction. Okay. Jonathan is having so much fun that he invites his other friend Sally. Okay. Jonathan pushes with 50 newtons of force. Okay, so we know force is 50 newtons. Okay. And boxes start to accelerate at 1.3 meters per second squared. Okay. If one of the boxes has a mass of 22.6, bless me. All right, if one of them has a box of, so one of the mass, we're going to call mass 1, is equal to 22.6 kilograms. So to solve this, what we're going to have is force is equal to our combined masses, right? Mass of 1, mass of 2, times the acceleration. Okay, so 50 is equal to 22.6 plus mass of 2 times our acceleration, which is 1.3. So if you divide that 1.3 over, I got 38.46. Oh, 38.46. And that is equal to our 22.6 plus mass of 2. So if you subtract the 22.6 over, I get a mass of 15.9 kilograms. Okay. Next one. Billy notices how much fun Jonathan is having. Okay. So he joins them. Both simultaneously push on a 5-kilogram box. Okay, so here's the box that's 5 kilograms. Okay. So let's see. Billy pushes with a force of 16 newtons. All right, so Billy pushes this way with a force of 16, oh, there we go, with a force of 16 newtons. Okay? However, the box accelerates towards him at 1.25 meters per second squared. Okay? What is the magnitude of force Tonathan is pushing? So Tonathan was over here, Billy was over here. So we're going to analyze the sum of forces is equal to the mass times acceleration. Okay? So the force of Tilly, we already know the force of Billy, right? Well, I'm just going to write it out. Force of Billy equals the mass times acceleration. So force of Tilly, Billy is pushing leftwards, right? He's pushing against me. So what it's going to be is negative 16 newtons is equal to the mass times the acceleration. All right, so force minus 16 is equal to 6.25. So I got 22 newtons. All right, using sig fig rules for adding and subtracting. Okay. Now, the next couple, we're going to be analyzing graphs. So if we look at this first point, so we're still looking at the sum of forces is equal to mass times acceleration. Okay. So if we look at this graph, on the left-hand side, on the y-axis, we have newtons. So I'm going to look at 1 newton. So when force is equal to 1, my acceleration is also equal to 1. So if I divide the 1 over, my mass is equal to 1 kilogram. Okay, that wasn't too bad. And if we look at this example, ooh, velocity time graph. Okay, so velocity time. So if I look at my 10 meters per second per 1 second, what's my acceleration? Well, it's just going to be 10 meters per second squared. So there's my acceleration. In the question, it tells me my mass is 5 kilograms. So 10 times 5. Oh. So 10 times 5 is going to equal 50. Okay. Now, if we look at this next graph, what I want you to do is look, 3 objects can only move on along a straight level path. The graphs below show the position of x of the objects plotted as a function of time. So it's displacement over time here. Okay, so what you're going to do is the net force of an object is 0. Oh, which of these has a net force of 0? Well, whenever there's a net force, that means there's no acceleration. Okay, so which of these displacement over time graphs show no acceleration? Well, it's always going to be the linear ones. All right, so this is linear and this is linear. So it's actually 1 and 2, or answer C. Okay, and to finish off today's notes, what we're going to do is we're going to analyze mass and weight. Okay, so mass is the amount of matter. Okay, and weight is the measurement of force due to gravity. Okay, those are the 2 differences. Now, what would happen to your mass and weight if you traveled on different planets? Mass would stay the same. Weight would change due to gravity. Okay. All right, so let me stop presenting. If you guys have any questions on this, just let me know. After watching this video, complete the PhET simulation, and you should be good to go. All right, so I hope you guys have a fantastic day, and we will see you tomorrow.